you're being asked to factor, you're basically being asked to write this as something times something. In effect, you're trying to figure out what you could multiply to end up with this. With this first problem, we're actually going to start with the factored form up here in gray and pay close attention to how we end up with each term in our trinomial. If you're given this, parenthesis next to parenthesis means to multiply, so we'll multiply each term by each term. So we'll keep our x squared. We can combine the two middle terms, and we simply bring this down. So how did we end up with this x squared? We multiplied x times x. How do we get this negative 24? We multiplied positive 12 times negative 2. I'm going to write negative 2 times 12. And how did we get our positive 10x? We subtracted. If the signs had been the same, we would have added. So the first and last term are the result of multiplication. This middle term is the result of addition or subtraction. Notice the numbers that give us this last term also give us this middle term. We will be using this fact in just a minute. Returning to our problem, where we're supposed to factor this trinomial, we can take care of the first term pretty quickly. We multiplied to get x squared, so if we write x times x, we'll get our x squared. To get the last term, since it comes from multiplying, if we list the factor pairs of 24, we'll have all the possible ways to get there. So now, whichever factor pair we grab, if we plug it in here and here, we can be sure that when we multiply, we'll get 24. To determine which factor pair to choose, have signs correct, and get the middle term, we need to know if we should add or subtract. The answer to that question comes from the sign of the last term. Since this last term is the result of multiplication and it's negative, we multiplied positive times negative or negative times positive. In either case, the signs are different. So the middle term must come from subtraction. That is, if this last term is negative, we'll be looking for a difference of positive 10. So if we're looking for a difference, that is, we're going to subtract and end up with a positive number. Looking at all these possibilities, it must be that the larger number is positive, the smaller number is negative. So which factor pair will give us the positive 10? That won't work. This one will. This one will not, and this factor pair would not work. Once you select the correct factor pair, you merely plug it in. This is the factored form of our original trinomial. If we want to factor this trinomial, it's similar to the previous one, but the signs are different. So to factor this, we can take care of the x squared pretty easily. It's the result of multiplication. So if we put x times x, we'll take care of x squared. For the 24, we'll list all the factor pairs so we can be sure to always get a 24 no matter what we plug in here and here. To decide if we're going to add or subtract these two terms, we look at the sign in front of our last term. This is the result of multiplication. If it's positive, we multiplied positive times positive or negative times negative. In either case, the signs are the same, so the middle term must come from addition. So if we want to add and get a negative value, both numbers must be negative, whichever factor pair we choose. So which factor pair would give us a negative 10? Not that, not that, not that, but this factor pair works. So you simply plug in negative 4 and negative 6. This is the factored form of our original trinomial. So quick review, if this is negative, you'll be looking for a difference to get your middle term. If this last term's positive, you'll be looking for a sum to get your middle term. I'll go over 3 more examples before we try a little mixed practice with 5 additional problems. So if you're asked to factor this trinomial, you're going to write it as something times something. You can take care of x squared without much trouble. For the 28, if you list the factor pairs, three won't go into 28, but 4 will. 6 won't work, and once you get to 7, you've already done that. So here are all the factor pairs of 28. And to decide which factor pair to choose, we look at the sign of our last term. If it's positive, we'll be looking for a sum of negative 11. So this wouldn't work. This wouldn't work. But if I have negative 4 and negative 7, I can add them to get negative 11. So I simply put in the negative 4, negative 7, and here's the factored form of our original expression. Looking at the next one, if we want to factor, we're going to write it as something times something. We can take care of the x squared pretty quickly. For that 48, I'm going to list the factor pairs of 48, and I'm going to go through it fairly quickly. If you want some practice with listing factor pairs, if you go to the first page of my website, the arithmetic page, the last 2 videos, prime number and prime factorization, and then finally multiples, factors, and factor pairs, should get you up to speed with listing factor pairs. but for a very brief review, 1 times the number always works. So 1 times 48, and then you just increase these digits. 2 goes in there 24 times. 3 goes in. If you add 4 and 8, you get 12. 3 goes into 12, so 3 goes into 48. It goes in once with 1 left over, which would be 18. 3 goes into 18 6 times, so it goes in 16 times. 4 goes in because if you double 2, you get 4, and you can cut that in half. It's an even number. 5 won't work. 6 goes in because notice that's an even number. So double 3, you get 6, cut that in half, you get 8. You try the next number, 7. 7 won't go into 48. By go into, I mean it goes in evenly with nothing left over. You try the next number, which is 8, and you already have it. So these are all the factor pairs, all the ways that you can multiply to get 48. To decide which factor pair, you notice the sign of your last term. If it's negative, you're looking for a difference. And in this case, it happens to be we're looking for a difference of negative 13. So can we subtract and get a negative 13 here? Nope. Nope. But if we had negative 16 and positive 3, we could get a negative 13. This wouldn't work, nor would this. So here's our factor pair. We simply plug in positive 3, negative 16, and we have the factored form of the original polynomial. By the way, when you factor any polynomial, you can check to make sure that your answer is correct. So if we want to check this, this gives us, combining these two middle terms, and so you can see here we have our original expression. Now here, if you're asked to factor, you say, all right, well, I can take care of the x squared with x times x. For this last term, I'll just list all my factors. And then based on the sign of the last term, if it's negative, I want a difference of this middle term, positive 10x. So can I subtract my way to a positive 10x? No, this wouldn't work. This would give me, nope. This wouldn't work. This wouldn't work, and this wouldn't work. So given all the factor pairs, there's no way to subtract and get my middle term. Therefore, this expression cannot be factored. You can write prime, because that's your answer, or if you feel like writing it cannot be factored, you're welcome to do that as well. If you'd like to pause the video and try these next 5 problems, I'll go over them shortly. Looking at number 1, for the x squared, for the 35, we'll list all the factors. 2 won't work, 3 won't work, 4 certainly won't because 2 didn't, 5 works, 5 times 7, 6 won't, and the next number is 7, which we already have. So here's all the factor pairs of 35. Since the last term is negative, we're looking for a difference of positive 34. So if we have positive 35 and negative 1, we'll get a positive 34. These factor pairs won't help. So we simply put in negative 1, positive 35. Looking at number 2, for the x squared, we'll have x times x. For the 30, four won't work because if I double 2, that's an odd number. I can't cut it in half. 5 goes in. And then when I get to the next number 6, I already have it. So to choose which factor pair, I look at the sign of this term. It's positive. That means I want a sum of negative 13. Since I want a sum, means the signs have to be the same. This wouldn't give me negative 13. If the signs are the same here, I'd get negative 17. That won't work. But here, I would get a negative 13. These two can't help me. So you simply plug in and be aware if you tried using a negative 15 and a positive 2, when you multiply, you would get a negative number. You have to multiply and get a positive. That's why these signs have to be the same. Looking at number 3, to factor this, we can take care of our x squared. For the 30, we'll list the factors. Noting that the last term is positive, we want a sum of negative 7. That is, again, the signs have to be the same. But if both signs are negative, there's no way to get a negative 7. So none of these will work, and this trinomial is prime. Again, if you put in a negative 10, a positive 3, you could get your negative 7, but you wouldn't get a positive 30 when you multiplied. Looking at number 4, we can take care of x squared again. For 60, we'll list all the factors. Two goes in, 3 goes in. We can double 2 and cut that in half. 5 goes in 12 times. If you can't do that in your head, just go off to the side and do long division. Anyway, when we get to 6, if we double 3, we can cut that in half. 7 won't work. 8, if we double 4, we can't cut the 15 in half. That's an odd number. 9 won't work, and 10 we already have. So here's all the factors of 60. Looking at the sign of the last term, since it's negative, we want a difference, and we want to end up with a -7. So these signs have to be different. So if we're trying to subtract and get -7, that won't work, that won't, nope, no, here, -12, +5, that would give us our -7. These two can't help us. So we simply plug in +5, -12, and we have the factored form of our original trinomial. And finally, looking at number 5, if we want to factor this, we're hoping we can write it as something times something. We can take care of the x squared. Let's see what it would take for this 24. Three goes in. 4 works. 5 will not go in there, and 6 we already have. So to decide which factor pair, we notice the sign of the last term is positive. So we want a sum of +10. So the signs must be the same. That won't work, that won't work, that won't work. But if we had +4, +6, we can get our middle term. So here's our factor pair. You just plug in the +4, +6, and you have the factored form of the original polynomial.